I'm Bill.
And I'm Corey.
Welcome back. This is our special edition of our
once in a lifetime show.
Our Leap Day show for Bill and Corey. And I was trying to figure out, hey, when's the next Leap Day for the Bill and Corey show? And I kind of looked at it, and it's every leap year the day shifts. The Leap Day shifts 5 days in the calendar.
Okay.
So, and it's like, okay. So the weekdays are 7, 5, it'd be 35 times 4, it would be 140 years. And then I realized, no, that's not how it works. Because on the century, you skip leap year unless it's divisible by 400.
Yes.
So the next one, the 2100s, we don't have and then it wasn't such easy for math. It was kind of a little harder there. So it's actually 2148 would be the next Bill and Corey show. Might be a different name by then.
Or it might be just telepathically shot into your head at that time.
And I don't know if there's leap days on Mars, so I don't know how that works. Okay, we'll get back to the real
regular scheduled program.
Regular scheduled program. We had a question come up. Someone was looking at our online store, store.mathesongas.com, and we have a section for gas cabinets. And they had a question on why a specific configured gas cabinet couldn't be used for acetylene service. That's a good question. So I knew the answers.
Luckily, they came to the right place.
We have different variety of cabinets available there. And the cabinet that they were looking at, that specific cabinet has a high pressure vent valve option. Acetylene, it gets kind of dangerous above 15 psi. It could go boom.
And that's not a high pressure.
No, that's not high pressure. So a high pressure vent valve is on the cylinder side of the regulator.
Yeah.
So it could be, if you had a cylinder nitrogen, it could be 2640 psi you're venting. Acetylene, you're talking a couple hundred, but it could go. We get flames. It could go boom, something like that. And we'll zoom in on this. This is acetylene gauge. This is what goes typically on a brass acetylene regulator for welding. So people who do welding stuff understand this. It's kind of got a red zone above 15 psi.
And red means what?
That's
bad or good? Okay.
That's bad. Red's bad in this case.
Okay.
So that's it. You can zoom back out. So So what we did was we now have, and since people had the questions, it's like, oh, okay, maybe we should have a acetylene specific gas cabinet if people are asking about it. So we put one on the online store, and you want to show first graphic. So there's different ways of finding things in the online store, and I like using the search bar in the upper left. And if you start typing acetylene, I did ACETY, then stuff with acetylene in the name is going to pop up.
As do most search bars.
Yeah,
so they work correctly.
You want to go to the next slide. And then, so this gets you a acetylene gas cabinet with pressure regulator. That's what we recommend. We've got a recommended safety. It's different features you can pick on the side, recommended safety package and stuff, and then the price will change and stuff. So you want to hit the next slide. This will show you the standard configuration. You can click on the hyperlinks, show you the specs on the 1177 cabinet.
It has a nice video that goes with it.
You get a video telling you about gas cabinets. We got the 54. We use a 54 series protocol station, single station manifold. We're recommending stainless steel on this. It'll be a 3510A series regulator, 15 psi max delivery pressure, of course. And we put a flash arrestor on there because you want to protect your equipment from a flashback, which could happen. So you want to go to the next slide. So then this tells you about the recommended safety package. Then you got blue hyperlinks if you want to look at the gas detection. We recommend gas detection in case there's a leak. You've got a shutdown controller and then an ESO valve. And the ESO valve will be on typically they're put on the inlet to shut off the gas source. But that's another bad thing. You don't want to have a quick closing valve on acetylene. It might go boom.
Yes.
So you put it on the outlet at a low pressure. It'll be 15 psi. Then it's safe to have an ESO valve.
Yeah, acetylene, I mean, it is probably one of the most it's a widely used gas, but it is nothing to take lightly.
Now, do we have the next slide. And that shows you some other shutdown options. Exhaust failure switch, that tells you when you lost exhaust in the cabinet. And then next slide. And this shows the other ones that kind of little accessory things that are kind of nice to have. But they're not, they're operate by them. So there's the MagnaHelic. That gives, it's a low pressure gauge, shows you the exhaust pressure in your stack. Fusible link option, which is kind of neat. You've got a great video on there. That's if there's a fire in the cabinet.
It's like a guillotine.
Guillotine shuts off the airflow coming in. And a diffuser plate with filter. That's, you put that on the inlet, and that keeps dirt from
getting in your
filter
cabinet.
out the dirt. Yeah. Okay, you want to get back to the regular screen?
Hey.
So, so that's for the acetylene. We have other gas-specific cabinets in there,
which is a new thing that we've just done. So
yeah, in the past couple months. So we got 2 acetylene cabinet, not acetylene. I'm sorry, hydrogen. We've got for 1 cylinder. We've got a panel in there. It's a 5500 series panel, 5300 series panel. I'm sorry. And then we've got hydrogen switchover
for 2 cylinder.
For 2 cylinders.
Wouldn't want to switch over for a 1 cylinder. That
and
would
then
be
I've
odd.
got another popular gas we sell in gas cabinets is ammonia. So I've got a 5-valve panel for that, and then I've got a 5-valve panel for toxic corrosive gases, just in general, and then semiconductor grade 9400 series panel for toxic corrosive gases. So you can find that, get ideas about what we can offer, and you can buy it. So next question we have is going to be for Corey, and there's a question the customer is asking about a 3010A.
3810A.
I'm sorry, 30. Did I say 30?
3010. That's,
okay.
I mean, it's
I meant
8-0.
It's just the sound got jumbled. So it's a 3810A, which is our dual stage regulator for ammonia service.
So yeah,
we got a 3810.
Well, this isn't a 30. This isn't a 38. It's the sister brass
it's
version.
The brass version.
Yeah, but it operates pretty similarly. So the first thing I thought when I heard it was like, oh, he's getting a dual stage regulator for ammonia. And this happens with many gases where the vapor pressure actually is lower than the first stage of the regulator. So the purpose of a dual stage, which we talked about a lot, is to get a supply pressure effect from the cylinder. As it drops in pressure, it'll raise the delivery pressure, and you don't want that. However, there are some gases that their vapor pressure is already low. Like, you can't get anything higher than what the first stage is, so the first stage actually does nothing except just let the gas pass through, and is actually non-functioning for the best. Yeah, it's just non-functioning. It's not doing anything. And of course, a dual stage costs more than a single stage. And I know I don't want to upset the bean counters, but I really, I don't want to oversell you something you don't need, So, but some people, like Bill was telling me, like these.
Well, actually, we'll talk a it. Ammonia has got a vapor pressure at room temperature of like 114 psi, and the interstage pressure is about 350 psi. So you're not doing
paying
anything.
for something you don't need.
Yeah. But, there's a lot of people who buy that.
Yeah, there are a lot of people, and for whatever reason, people want it and people buy it. But I'm just going to, if you want it, hey, more power to you. You can still use it. However, we also have, and we'll grab this guy.
Okay.
We have actually a specialty regulator, for ammonia because it is a.
You're talking about the dual stage specialty?
Let's do this. Yeah. So
okay.
Bring up the graph. Good time. Do you have the graph for the? Showing the regulator selection guide.
Oh no! Oh, you want to do that now?
Yeah, well, we can tell you. Yeah.
Okay, bring up the.
Yeah. So here we go. Here's our regulator selection guide, and I wish we could promote this more, and because it's a really handy tool. And as you can see down there, there's ammonia.
You want to go ahead, next slide?
Next slide.
So, actually, there's.
Oh, there we go. Yeah, there we go. Note. Yeah. So we just want to highlight this. Some regulators have no recommendation shown. That's because there's no appropriate recommendation to be made. And that's because some have low cylinder pressures, and so you don't have to worry about supply pressure effects. So a lot of times you'll see a single stage recommendation, but no dual stage recommendation. Yeah. And that's because, the dual stage isn't going to help you anything more than that.
You want to go to the next slide? There, and that's ammonia.
And that's ammonia. And this one does have a dual stage, and we'll explain in a little bit. Yeah. So this is the dual stage ammonia regulator.
Back to camera.
This is the dual stage ammonia regulator. Now, unlike the dual stage here, this one has a first stage pressure of 350. This one is specially made with a 60 psig first stage, and the second stage is 0 to 30 psig delivery pressure. And so some people want a dual stage.
Yeah, we have one specific customer
Yeah.
that we designed this for, and they buy tons of them. But it's specific. It's 30 psi delivery pressure, and they want it, whatever their application is. It's very important to them.
Yes.
So
Unlike most, ammonia does have a special dual stage, low pressure dual stage regulator. Now this is what we would recommend for it. This is our 3610A, it's a single stage. And as you can see, it has a cross purge on it, which is for drying it out. So if moisture is the enemy of ammonia, and even the one that he was doing anhydrous
it's
ammonia.
also toxic too.
It's also
So you don't
toxic
wanna
too.
Breathing in ammonia.
You don't want to be breathing in ammonia. You got me saying it the wrong way. Ammonia. And also, if water is or moisture, I should say, it will make the ammonia
you get a little
corrosive, and it can mess with the regulator, shorten your lifespan of your regulator, and when it gets corroded, it makes it more dangerous to use. And so we recommend it with a cross purge, and this is also a tied diaphragm valve. And what a tied diaphragm valve is, it really prevents it from ever getting to the bonnet because it's tied.
Well, actually, what it does is it gives a more positive seal.
Yes.
So it's like what's nice is if you get a little bit of corrosion on there, it's going to yank it a little harder. So it's going to crush kind of the corrosion.
It's going to crush, yes. So because it's tied, the diaphragm is tied, whereas in regular ones, it kind of just sits on top and gets
kind of floats there.
It kind of floats there and it gets pushed down.
Yeah, it's a pressure thing. So
So this is the one we would recommend for ammonia, and do the cross purge in order to extend the life of your regulator, and also to make it safer when you have to change cylinders.
Of course, if you have pneumonia, you should stay home from work.
You should stay home from work. But by the way, the reason why I keep saying that is Bill's been saying pneumonia, and finally said, you're pronouncing it wrong. And he goes, I know, I'm doing it on purpose. And I think he was doing it to annoy me, and it finally got to me, and now I'm saying it wrong.
Okay. So, the next one's another interesting, it's like a history lesson here. So,
yes,
Bill
this one's a good
show, it's not only, it's just learn a little, laugh a little. So
we haven't highlighted scientists in a while. We should probably look to do that more often.
Highlight scientists? Okay.
Like Bernoulli, I don't know. But anyways, go ahead.
Okay. So we had a question. Someone was looking for a regulator for perfluorobutane, that's C4F10. And they said they wanted it with a CGA 668. And I responded back to the salesperson who asked me about that. I said, I think that's a typo. It really should be 660 because that's one of those liquefied gases, refrigerant gases.
Wait, they are refrigerants.
Well, they are refrigerants.
They're not.
Using in your refrigerator.
Well, you used to use ammonia to refrigerate back in the day.
Yeah, but it's I don't think you're using pure fluorobutane.
That's true. That's true.
Saying that. So I was like, that just seemed weird. Maybe they mistyped it. And then I got a thing back. Oh no, they got this out of our gas data book, which is kind of neat because they downloaded
They used it. Yes.
They downloaded our gas data book, which just put up last year. So I was like, this is great. So I took a look at it. You want to put up the first slide? So there it is, 668. I go, okay, that's just a typo. Yeah, maybe the typo in the book. It's got
multiple typos.
700 pages. It's a one-page typo.
Yeah.
Okay, you want to go to the next page? Oh, look, it's all over the place. It gets the regulator, and I go, that's not a typo. You're not really messing things up unless you had some rookie handling this page. So I got a buddy of mine who works at CGA who's been in the business for a long time, used to work for Matheson, and asked him about, hey, what do you know about CGA 668? You can take the graphic away. I'm going to miss my thing about pure fluorobutane. Okay, this connection was originally called a C7C and was assigned to refrigerant gases, which is considered refrigerant gases. This design, the 668 design is based on the CJ 660 valve, outlet, but the outlet's bored larger and deeper with a longer and larger nipple to prevent interchangeability with a new connection 666. And he got this out of some note, and then he looked up 666 and he couldn't find anything on 666.
The devil's CGA.
Yeah, something like that. And he said in CGA 668 was used up to mid 1980s and it was phased out.
There you go.
So so there are some old CGA fittings that just kind of disappeared. They went in that. So
Went the way of the dodo bird.
and there's something that Matheson came up with. 'Cause back in the day, people just way long ago,
Back in the day.
way 70, 80 years ago, people kind of made up valve fittings.
It was the Wild West.
Yeah, it was the Wild West, and that's why the CGA got together. And goes, no, we need to make standards on this, because then you got someone's gas cylinder, you can't hook it up for your application because it's some proprietary connection and stuff like that. So Matheson came up with, they made up their own
Proprietary connection.
proprietary. They call it the 665, which is kind of like, and I kind of made one up here. It's kind of like a 660 nut, which is used for ammonia. And ammonia's got a large nipple, so it's got, oh, you want to zero in on that? So that's got a large diameter hole there because ammonia nipple's bigger, probably for interchangeability things. So we had the nut made with a smaller diameter, and we used a 350 nipple, which is flammable. So if you had a custom nut and you had a smaller diameter, you could make something. And that would be on our. We use this as a inlet fitting on our manifolds, our multi-station manifolds. The stainless steel ones would have a 665. So the flex hoses you'd hook up for stainless steel.
But we no longer use those.
We no longer use that. We phased that out in the 2000s.
Now we use. Oh, okay, wow, that was late.
So, oh wow, we ran
went
kind of late
long.
today. So yeah, we only got through 3 questions, so that's
That's
fine.
okay. That leaves some more for the leftovers.
Yeah, so we should do a leftover podcast tomorrow. So we'll cover that over and hopefully bring some leftovers in, maybe some tea or coffee or something like that. So thanks for tuning in to Bill and Corey Show. Tune in again next week for another episode.
Set your VCRs.